Good morning. This is our manufacturing presentation done by Muhammad Sultan, Muhammad Yusuf, Basil, and Omar, and Muhammad Ashawaf. What is the radiator, its purpose, and where it's used? A radiator is the key component of the engine cooling system. Its main rules displace a mix of antifreeze and water through its fan, which release some of the engine heat while taking in cool air before continue to pass the rest of the engine. What is the radiator? Okay. Within the radiator itself, it has three main parts known as the outlet and inlet tanks, the core, and the pressure cap. Each of these three parts play its own role within the radiator. The main role of the radiator hose is to connect the engine to the radiator and allow the coolant to run through the respective tank. The inlet tank it's in charge of guiding the hot coolant from the engine or to the radiator to cool down. Then it circles back out to the engine through the outlet tank. After the hot coolant comes in, it circles through a huge metal plate that contains multiple rows of thin metal fins that help cool down the incoming hot coolant, called the core. Then it's returned to the engine through the outlet tank once the coolant is at the appropriate temperature. While the coolant undergoes such as a process, there is also the pressure or radiator cap, whose role is to tightly secure and seal off the cooling system to make sure it stays pressed till a certain point. When it reaches that point, it will release the pressure. Without the pressure cap, the coolant may overheat and cause an overspill, thus causing the radiator to work inefficiently. Radiator is the name given to the part that transfers the heat received from the engine to the air. It performs the cooling process by keeping the maximum amount of water in its channels and contacting a large area of it with the atmosphere. It consists of honeycomb consisting of water carrying channels and the upper boiler that provides water entry and the lower boiler that sends it back to the engine. Some radiators are slight boiler. During the operation, the water in the engine comes to the upper boiler and it's distributed to the ducts from above. As the water flows down the channels, it loses its head with the incoming airflow. Types and structure. Radiators are named according to the shapes of the pipes that provide water passage and the tin sheets soldered decoupled between the pipes. Although there are various radiator honeycombs, two types are most used in passenger cars, tubular and flat air fins. In terms of heat distribution, the larger rate that more cooling efficiency it has, the radiators are classified depending on the honeycomb shape. The type with the slotted fin seen is the most used type. In this type of radiator, there are pipes made of copper or brass material between the upper and the lower radiator tanks. Creative fins are attached, digging between the pipes with the solder. Aluminum radiators have recent upper and lower tanks, and honeycomb fins made of aluminum material are used more often because they are lightweight.
Okay, I will continue talking about types and structure. Tubular types radiators. These radiators consist of a number of round and flattened water pipes, which is called water tubes, soldered to the header places of the lower and upper water tanks. Usually, the water pipes are placed upright. Sometimes there are also horizontal flow radiators. Air fines are made straight or curved from thin copper or brass material. These fines are soldered on water pipes. These solders ensure that the water pipes stand firmly, as well as taking heat from the pipes better and transmitting it to the fins. The fins, which provide a large contact surface with the air, give the heat to the air. There are bellows-shaped plates between the fins and pipes parallel to the pipes decked inside. Radiator production process. When the gasoline in a car engine burns up to 70% of energy generated, hits this heat goes out the exhaust system, but Much of it stays, heating up the engine, the car's cooling system. Prevents overheating. The system's key component is the radiator. A water and antifreeze mix absorbs the heat generated by the engine. The fluid then flows through the radiator's tubes to cool down the tubes, which is made by power-thin brass roller bend the 4 centimeter wide strip into shape of a flat tube. The tubing then runs through a vat of a bubbling hot molten lead. As the tubing exists, the vat it runs through cold water that hardens the lead coating, and the cutter then chops the tubing into pieces the length through cold water, of which varies according of the model of radiator. These are about 76 centimeters long. Meanwhile, another machine shapes a narrow strip of copper, just 1/2 millimeters thick, into what are called cooling fins. As we'll see in slow motion, the machine folds the copper strip fan then perforates it into creating mini air vents. When the hot fluid runs through the tubes, these fins will transfer the heat to the air flowing through the radiator. Cooled fluid can then go back for another round of absorbing engine heat. The cooling fins come out machine cut to size. Then workers manually stuck the tubes fins one on top of the other. Types and structure. They straighten them out, then applies a brass tag indicating the model number, a date production. Then they compress a strap the component together. Elsewhere, a computer-guided machine punches out a pattern on brass sheets. These will become what are called headers. There is one on each side of radiator. The punching tool they then changes to a knife, which now cuts along the perforation lines. Using a press, they each header then punch slots for the radiator's tubes. Now, using a mallet, they hammer and the headers onto the ends of the tube, banging infinitely closes a few tubes. So they use a special roller to reopen from after cleaning the surface into an oven at 350 degrees Celsius in just 2 minutes. The lead melts, fusing the tubes and cooling fins. After straightening out any crooked tubes, workers dip the headers into a tank of a hot liquid for 30 seconds. This solders them to the sides of radiator. And these are the materials used for the radiator: auxiliary radiator, mount bracket screw, drain plug, thermostat O-ring, water outlet, battery tray bolt, tank assembly, radiator overflow, battery tray bolt, radiator screw, cap, coolant hose, inlet duct seal, and radiator coolant hose C-clip. And this is a program for material used for the radiator. Okay, Omar.
I will continue about radiator parts. Automobile radiators contains of two headers tanks connected by core with numerous vent tunnels, providing ample surface area of efficient cooling. Traditionally, radiators featured brass of copper cores soldered to brass headers. Modern version opt for plastic headers and aluminum cores to reduce costs and weight. However, this construction is more challenging to repair compared to traditional materials. Coolant. A car engine generators heat during operation, risking overheating and potential damage. The radiator circle in water cooling engines. Engine temperature by correlating column. Key components include the radiator's water pump, hoses, thermos, and cooling fan. By working together, these parts ensures the engine stays within a safe temperature range. Next, please. Okay, cooling fan. The cooling system uses outside air while the vehicle runs, but activates a fan during idling of traffic stops when air intake is low. This supports radiator airflow, improving cooling. Yes, next. Water pump. So the water pump transfers coolant to the engine's water jackets, radiator, and receiver. The thermostat maintains a constant coolant temperature and halts flow in extreme cold. The radiator cap with pressure and vacuum valves regulate pressure, venting expects liquid, and return coolant to the radiator when pressure drops. Yes, next. Okay. Pressure cap. The pressurized coolant in the radiator can withstand higher temperatures within boiling, enhance efficiently. The radiator pressure cap regulates coolant drinks to prevent damage from overheating as the cooling fluid heats up and expand. Pressure resist. Which the valves opens to the released excess coolant.
Okay, so pressure cup. This coolant passes via the overflow tube and into the overflow tank's bottom. This configuration prevents air from entering the system. When the radiator cools down again, a vacuum is generated in the cooling system, which causes another spring-loaded valve to open, pulling water back into the overflow tank from the bottom to replace the water that was lost. Around the cylinder head, valve seats, and any other hot parts that need to be cooled, cooling water jackets are installed. The heat generated in the engine cylinder is transferred to the jackets via the cylinder walls. Radiator definition parts, cooling water jackets. The heat is absorbed by the water running through the jackets, which heats up. After that, the hot water will be cooled in the radiator. Here's a photo of a cooling jacket radiator. Now, outlet and inlet tanks of a car radiator. The smooth flow of the water into and out of the radiator is controlled by the outlet and inlet portions of the radiator. It may be found in either a metal or a plastic radiator head. The hot coolant travels from the engine to the radiator through the intake area and back to the engine through the outer portion. Antifreeze mixture. If the water used in radiators in Western nations freeze, freezes due to cold conditions, the resulting ice has a large volume and causes cracks in the cylinder blocks, pipes, and radiator. The car radiator antifreeze mixer or solutions are added to the cooling water to avoid freezing. Car radiator antifreeze solutions that are optimal should contain the following characteristics. It is easily dissolved in water. It doesn't go away. It does not cause any foreign stuff accumulate in the cooling system. It has no negative impact on any aspect of the cooling system. It is inexpensive and widely available. It has no corrosive effect on the system. Reserve tanks. Coolant expands as it heats up. Because the cooling system is sealed, this expansion results in a rise in cooling system pressure, which is standard and part of the design. When a coolant is under pressure, the temperature at which the liquid boils is much greater. This pressure, along with ethyl glycol's greater boiling point, allows the coolant to safely reach temperature beyond 150 degrees. The radiator pressure cap is a basic mechanism that keeps the cooling system pressure constant up to a specified point. If the pressure rises over the specified pressure, a spring-loaded valve calibrated to the right pounds per square inch, which is PSI, will open to relieve the pressure. Okay, so automobile radiators are made of a pair metal plastic automobile radiator are made of a pair of a metal or a plastic collector tanks connected by a core through many narrow passages, which gives a large surface area relative to the volume. This core is usually made of stacked layers of sheets of metal that are pressed and soldered together to form channels. For many years, radiators were made of brass or copper cores soldered to brass heads. Modern radiators have an aluminum core and usually save money and weight by using sealed plastic caps. This structure breaks down more easily and is more difficult to repair than traditional materials. The previous method of construction was honeycomb radiator. Round pipes were forged and in the form of hexagons at the ends, then stacked together and soldered decently. Since they only touch at the ends, this would form a solid water tank through which many air pipes pass. Some older model car use radiator hubs made of coiled tubing, which is less efficient but simpler structure.
Okay, let's continue with role of coolants in the car radiator. The car radiator principle involves air or a liquid coolant circulated through a heat exchanger called radiator. Cooled by air is used to cool most internal combustion engines. Some stationary engines like marine engines have immediate access to huge volume of water at an appropriate temperature. Also, water may be used directed to cool the engine. It frequently contains debris which can block coolant tubes as well as compounds such as salt, which can harm the engine chemically. As a result, engine coolant might be circulated via a heat exchanger that is cooled by a body of water. Water and chemicals like antifreeze and rust inhibitors are used in most liquid-cooled engines. Engine coolant is the industry term for the antifreeze mixture. Some antifreeze employs a liquid with different characteristics than water, such as a propylene glycol or mixture of propylene glycol and ethylene glycol. Liquid and air oil cooling. To keep essential engine parts and the oil at appropriate temperatures, most air-cooled engines employ some liquid oil cooling. Most liquid-cooled engines employ some air cooling. With air cooling, the combustion chamber during the intake stroke. Wankel engines are an exception, as some portions of the combustion chamber are never cooled by intake, necessitating the more effort for proper operation. Cooling is influenced by the qualities of coolant, water, oil, or air, it depends. When comparing water and oil as coolants, for example, 1 gram of oil can absorb around 55% of the heat for the same temperature rise. This is known as the specific heat capacity. There are some requirements for air cooling. As oil has density around of 90% of water, a given amount of oil can only absorb about 50% of the energy that the same volume of water can. Water has a thermal conductivity of around 4 times that of oil, which can help with heat transmission. Oil's viscosity can be 10 times that of water, increasing the energy required to pump oil for cooling and lowering the engine's net power output. When comparing air and water, the air has a lot lower heat capacity per gram and per volume. It's 4,000 and a tenth of the conductivity, but it also has a much lower viscosity, approximately 200 times lower, 17.4, 106 PA for air versus 8.94, 104 PA for water. And also we can continue requirements for air cooling. Continuing the computation from the previous two paragraphs, air cooling requires 10 times the surface area, which necessitates the fins, and air requires 2,000 times the flow velocity, necessitating 10 times the power of a recirculating water pump. Moving heat from cylinder to a wide surface area for air cooling can pose challenges, such as creating geometries required for efficient heat transfer and providing enough room for a big volume of air to flow freely. As you can see, there's a scheme here on the left. And that's it for the presentation.